Let's discuss a physical chemistry topic today on azeotropes. An azeotrope is a specific mixture of two or more liquids that boils at a constant temperature and cannot be altered by simple distillation. To explain how an azeotrope behaves, let's look at the classic example of ethanol, alcohol, and water. This combination perfectly demonstrates a minimum boiling azeotrope. Let's discuss with an example, with a lab diagram.
Imagine we have a mixture that is mostly water, and we want to purify the small amount of ethanol inside it using fractional distillation. In an ideal world, we would just keep boiling the liquid. Normally, ethanol, which boils at 78.37 degrees Celsius, turns into vapor much more readily than water, which boils at 100 degrees Celsius. When you start the process, shown here in panel A, the vapor that rises will always have a higher percentage of alcohol than the liquid left behind. We can keep repeating this condensation and reboiling process up the column. We can easily get to 50%, 70%, even 90% pure ethanol this way. But then we hit the azeotrope wall. When the solution composition reaches exactly 95.6% ethanol and 4.4% water, everything changes. At this precise point, the negative interactions between the water and the alcohol weaken the solution, making it unusually easy for both components to evaporate. The whole mixture begins to boil uniformly at just 78.2 degrees Celsius, lower than either pure substance. Look closely at the molecules leaving the surface in panel B. Because the entire system boils as one unit, the composition of the vapor is exactly the same as the composition of the liquid. Distillation completely stalls. We cannot go any higher.
Hitting the azeotrope wall. You can keep repeating this process to get 50%, 70%, and then 90% pure ethanol. However, the moment the mixture reaches exactly 95.6% ethanol and 4.4% water, the process completely stalls. Why does it stop changing? At this precise 95.6% concentration, the liquid and the vapor have the exact same composition. The theory of azeotropes is just half the battle won. To completely crush your upcoming exams, you need to see how these concepts twist into competitive numerical problems. Tap the playlist right here to unlock the complete step-by-step masterclass series on WaveEduAi, and make sure to check out our regional subchannels for localized board prep blueprints. Click, subscribe, and let's keep learning.